today we'll study about the transform. ये तुम्हारा इसमें मैं कवर ये तुम्हारे सिलेबस इंस्ट्रक्शन EMF equation and all this. Okay, so first of all we need to learn about exactly what is transform. Now you tell me transformer का क्या है? What do you mean by the transform? Where do we use transformer? Tell me. I'll tell you example. Like in this will अब मैं Nangal Dam, right? Have Bhakra Nangal. You know what is Bhakra Nangal Dam? Basically a hydroelectric power plant. You have learned. Like here the electricity is generated and in India at 11 kilometers will have 11. Now we transfer this electricity up Delhi, suppose. Now as you know that will have one formula equal to have so much amount of less voltage, 1000 voltage. Voltage is less, then current will more or not? Tell me, our voltage is less than current. If current is increasing for the square. If current increases, then loss also increases. Yes or no? If current increases, then so what we want to decrease our loss, correct? And how can we decrease our loss? Then in that want to decrease losses and voltage should, and so for that we need to increase a high level. So for that we'll transformer in the tab across the bhag, and that transformer is known as step up transformer. That transformer is known as step up transformer. Like from 11, like in India we'll have the maximum allowable limit 65 kilovolt. So that depends on our requirement up to where we want to increase. Okay, understood this point? Then now the electricity up to, and it will reach up to 20 low up to 20. Now we don't want such a high amount of voltage, right? So we decrease the voltage from 1 kilovolt, right? So for that we need step transform. The now in Delhi city is transfer in us like West Delhi. Now as our home requirement is how much voltage want our home 20 to 40 volt. So again the yeah, this is a very voltage. So again transform. Understood? Transformer is step up and voltage, or we step down. Now you got to know why there is a need for the transform. Okay. So next thing, construct how the transformer working principle. So in this case we'll have transformer like this. In every kind of transformer we'll have primary winding and we'll have the secondary winding, correct? We'll have the supply voltage, that is V. This will have the at the low side in the, like just imagine this is the government side. Government side say you are getting the supply, and this is the secondary the load side. Load side that you are getting electricity at your home. Understood? So this load is just like our home says, like we are using H, all these comes. Primary side is always denoted by the term 1 and second always denoted the term. In this will have the number of terms n1. This will have this n2. Current flow is I1. Current flow is I2. Right? This one is V1. This one is V. Understood? Now tell me. Doubt up to here? In this material will have this is the AC supply. Right, right. Okay. Now next we'll have types of, one is transform, the step transform. Transform, if number of terms second side is more, case will have step up transform. N2 is one have step up transformer. If N1 have step down transform. Okay? अगर हमारे पहले number of turns ज़्यादा है, this voltage is higher, right? If we'll have less number of turns, then this voltage is less over. Or will be the number of the voltage, and on the basis of that we'll step up transform a step. Got it? One thing. Next thing, like suppose we'll have, then in that case, if we'll have like suppose we are giving supply of V1, then in that case EMF will induce, right? And how the EMF for that will have particular is law of electromagnetic. I think you have heard of scientist, right? Faraday what says that E equal to n phi by, what is d phi by flux with respect time. Okay, it would flux respect time. Now the question is how flux will, because he says if will flux will change, then in that case EMF will induce flux, then in correct. Now the question arises, will change as you know, current, right? If current is, so that means if will, in case I or DC supply current with of AC or DC supply, current will of AC supply. Now current is flux induced, yes or no? Current is changed, that flux will also. So for this one reason that transformer works C. Why is it C supply? If this is constant, no, apart from that, if C supply have the flux. If flux is changed, flux is, then in that case, EM a transform. And it depends on the number of turns also. If there will be more number of turns, and if there will be types of, like suppose primary wire, that kind of cell, and from the EM at the second shift for of, right, self. But if shift, correct, supply, that kind of primary wire, understood. Yeah. So now, right, whether have part N1 I maximum, F is for I F flux N2, correct. As I told, I because, right now, if I these two, I am divide these two out, E, right. If N is similar and current is always, then opposite I1 I2, and all these terms in the formula for system, which will transform. This is the formula for primary and thousands and thousand, 6 square. Now the set primary says primary given. Now they ask you to calculate density. Basically, phi m is phi m lux bm lux, and the, the flux unit is per, that's denoted, and a is meter square, right? So if you calculate per per 1 Weber per meter. Now back to the task, the calculate the flux density, right? Task you max means you ask you the for bm im or phi is even n1, correct? Any doubt up to 50 im with now substitute im. Im again. What you got from this is the understood. Now in the we need to calculate, as I took transformation by n of the vector five 500. Got it? What it is? M is 1 per meter. Pm 5m, right? Solve it. 1000 to